Alright, so to continue our discussion on exponents, I'm going to talk to you about how to divide with exponents. And yesterday when we were talking about multiplying with exponents, whenever we were multiplying exponents that had the same base, the trick was to, that looks awful, but the trick is to keep the base and add the exponent. So 5 plus 3 is 8. Well, when you're dividing, you do the opposite. And so I think of it as dividing being the opposite of multiplication. Well, since when you're multiplying, you add the exponents, dividing, you subtract the exponents. So here in this example right here, you can see 3 to the power of 5 over 3 to the power of 3 simplifies to 3 to the power of 2. Now, if you're ever unsure what the rule is, always write it out in expanded form. 3 to the power of 5 is 3 times 3 times 3 times 3 times 3, and 3 to the power of 3 is 3 times 3 times 3. So when you simplify it out, this all cancels out. Anytime you have a numerator and the denominator are the same, such as 3 over 3, that's just equal to 1 whole because they cancel each other out. Well, that's what's happening here. The 3's over 3's are just canceling each other out, leaving me with 2 3's here, which is 3 to the power of 2. Or you can simply subtract your exponents. So here on these examples, I've got 2 to the power of 7 over 2 to the power of 2. Because they have the same base, the base is 2, and 7 minus 2 is 5. So this simplifies to 2 to the power of 5. This example here, they have the same base, which is x. 4 minus 3 is 1, so this is x to the power of 1, which is simply x. And again, if you're not sure, try writing it all out in expanded form. X to the power of 4 is x times x times x times x over x cubed, which is x times x times x. And so I can cancel out whatever is the same on the top and bottom, and they don't have to be right over each other, you know, just for future reference. And so when I do all that, that leaves me with 1x, which is the same thing that we got right here, that x over to the power of 4 over x cubed is equal to x. Here in this example, again, they have a common base of 2, and 9 minus 7 is 2, so this simplifies to 2 to the power of 2. Now here, this is y over y to the power of 4. There's not a 1 here, but that's the same thing as saying y to the power of 1. 1 minus 4 is negative 3. So this simplifies to y to the power of negative 3, which from previous discussions we've learned that's the same thing as 1 over y cubed. Now, if this confuses you, what I like to think of is that when I write it out in expanded form, when I write all this out, I have y over y times y times y times y. And so when I do that, I cross out my common y's, and I end up with 3 y's on the bottom, which you can see you have 3 more y's on the bottom than you do on the top. So that's why another reason that this simplifies to 1 over y cubed. Now there are going to be times when you are cubing a fraction, and so when you're doing that, you are going to distribute that power, that exponent, to everything that's inside the fraction. So 2 over 3 cubed is equal to 2 cubed over 3 cubed. So here, if we were to simplify this, this would be equal to 4 squared over 7 squared. Now I know that this could be simplified even more to 16 over 49, but we're not going to do that right now. We're just working on simplifying our exponents. Okay? So for this example, this is equal to 3d squared, and all of that to the power of 4 over EF to the power of 4. And again, now I have to apply my rule where I distribute my power to everything that's on the inside. So this is going to simplify to 3 to the power of 4, d to the power of 8, that the 4 goes there, and then this 2 times 4 right here is 8, over e to the power of 4 times f to the power of 4. And this is all Again, I know that 3 to the power of 4 simplifies to 81, but for these purposes, we're just going to leave it where it is right now, okay? All right, this example is 2 cubed squared over 3 squared squared. Excuse me. And so when I simplify this, I remember I can multiply my powers, so this is going to be 2 to the power of 6 over 3 to the power of 4. This example here is going to be a cubed times b, and all of this is cubed, over a squared b squared, and all of this is cubed. And so this is going to simplify to a to the power of 9 times b cubed over a to the power of 6 times b to the power of 6. Now what I hope you realize here is that this can be simplified some more. A to the power of 9 over a to the power of 6 simplifies to a to the power of 3, and b to the power of 3 over b to the power of 6 simplifies to b to the power of 3. Okay? Now, there are times that you're going to have a negative exponent. And so from a few days ago, we discussed how anything that's to a negative exponent is the same thing as saying 1 over that exponent to the positive power. So x to the power of negative 3 is equal to 1 over x cubed. And I'm sorry that that looks so bad. Well, if you think about it, really what you're doing is you're taking what's up top, moving it to the bottom, and taking what's on the bottom and moving it to up top, to be on the top. You're swapping your numerator and your denominator and making the bottom positive. So that's what you are going to do here. You're going to say that this is the same thing as 4 over 3 cubed. And it's now positive. I've swapped my numerator and my denominator, and I made my exponent positive. So I can use that to apply it to this. So again, I'm going to swap my numerator and my denominator, bring that down, and then I'm going to square all of this. And so then I'm going to apply those rules where this is squared up top, so this becomes y to the power of 6. This is squared on the bottom, so this becomes 2 squared x to the power of 4. And again, we know that 2 squared simplifies to the 4.